Imagine the ground beneath your feet suddenly shifting with the force of thousands of tons of dynamite. That's exactly what happened to residents of southern Philippines when a magnitude 6.1 earthquake struck near Dapa, in Surigao del Norte province, just hours ago. This isn't an isolated incident. It's the latest in a series of powerful tremors that have been rattling this region, leaving dozens dead and thousands homeless in just 1 week. The Philippines sits on one of the most seismically active regions on Earth, and understanding why requires us to look deep beneath the ocean floor. The country lies along the Pacific Ring of Fire, a horseshoe-shaped zone where roughly 90% of the world's earthquakes occur. Here, massive tectonic plates collide, slide past each other, and dive beneath one another in a constant geological dance that's been going on for millions of years. The Philippine archipelago is particularly vulnerable because it sits at the intersection of 3 major tectonic plates: the Philippine Sea Plate, the Eurasian Plate, and the Indo-Australian Plate. These plates don't move smoothly. Instead, they stick and slip, building up enormous pressure over decades or centuries before releasing it in violent bursts we call earthquakes. Today's magnitude 6.1 earthquake near Dapa represents a significant release of energy. To put this in perspective, a magnitude 6.1 earthquake releases energy equivalent to about 500,000 tons of TNT. The shaking can be felt across hundreds of kilometers, causing buildings to sway, roads to crack, and in worst cases, structures to collapse entirely. Surigao del Norte province, where today's earthquake occurred, has experienced this geological violence before. The region sits near the Philippine Trench, where the Philippine Sea Plate dives beneath the Philippine archipelago. This subduction zone is an earthquake factory, constantly generating tremors as the descending plate grinds against the overriding land mass. What makes this recent seismic activity particularly concerning is the clustering effect we're witnessing. When one significant earthquake occurs, it can trigger others along nearby fault lines. The stress released by the first earthquake gets redistributed across the surrounding rock, sometimes loading nearby faults closer to their breaking point. This is why we often see earthquake swarms or sequences, where multiple significant tremors occur within days or weeks of each other. The human cost of these geological forces cannot be understated. In the past week alone, dozens of people have lost their lives, and thousands of families have seen their homes reduced to rubble. Each earthquake doesn't just shake the ground, it shakes entire communities, disrupting livelihoods, separating families, and forcing people to rebuild their lives from scratch. Modern seismology helps us understand these events, but predicting exactly when and where the next big earthquake will strike remains one of science's greatest challenges. Scientists can identify areas of high seismic risk and estimate the probability of future earthquakes, but pinpointing the exact timing is virtually impossible. This uncertainty makes earthquake preparedness absolutely crucial. The Philippines has been working to improve its earthquake preparedness and response capabilities. The Philippine Institute of Volcanology and Seismology continuously monitors seismic activity across the archipelago using a network of sensitive instruments. When earthquakes occur, this data helps scientists quickly determine the magnitude, depth, and potential impact, enabling faster emergency response. Building codes have also evolved to help structures better withstand seismic forces. Modern earthquake-resistant construction techniques can significantly reduce casualties and property damage. However, implementing these standards across thousands of islands and millions of structures remains an ongoing challenge, particularly in rural and economically disadvantaged areas. The depth of an earthquake plays a crucial role in determining its impact at the surface. Shallow earthquakes, those occurring within the first 70 kilometers of the Earth's crust, typically cause more intense shaking and damage than deeper ones. Today's earthquake, like many in the Philippines, likely originated in the shallow crust, where human populations are most vulnerable to its effects. Seismologists use multiple scales to measure earthquake magnitude, with the moment magnitude scale being the most commonly used today. This scale is logarithmic, meaning each whole number increase represents a 10-fold increase in amplitude and roughly 32 times more energy release. A magnitude 6.1 earthquake like today's releases about 1,000 times more energy than a magnitude 4.1 tremor. The psychological impact of living in an earthquake-prone region cannot be ignored. Constant seismic activity creates a persistent undercurrent of anxiety in affected communities. People develop heightened awareness of potential escape routes, keep emergency supplies readily available, and sometimes struggle with sleep, as minor tremors remind them of the ever-present geological threat. Climate change adds another layer of complexity to earthquake impacts. While climate change doesn't directly cause earthquakes, it can influence their secondary effects. Rising sea levels can worsen tsunami risks from offshore earthquakes, while changing precipitation patterns might affect landslide susceptibility in earthquake-damaged terrain. International cooperation plays a vital role in earthquake monitoring and response. The United States Geological Survey, which reported today's earthquake, maintains global seismic monitoring networks that help provide rapid information to affected regions. This international collaboration ensures that earthquake data reaches emergency responders and the public as quickly as possible. Technology continues to evolve in earthquake detection and early warning systems. Some countries now operate earthquake early warning systems that can provide seconds to minutes of advance notice before strong shaking arrives. While this might not sound like much time, those precious seconds can allow people to take protective actions, stop elevators at the nearest floor, and halt dangerous industrial processes. The Philippines' location in the Pacific Ring of Fire means that earthquakes will continue to be a fact of life for its 109 million residents. Today's magnitude 6.1 earthquake near Dapa serves as another reminder of the dynamic forces constantly reshaping our planet. While we cannot prevent these natural phenomena, understanding them better helps us prepare, respond, and ultimately build more resilient communities. As rescue and relief efforts continue in the affected areas, the focus remains on immediate humanitarian needs. However, each earthquake also provides valuable scientific data that helps researchers better understand seismic processes and improve future preparedness efforts. In this way, even tragedy can contribute to knowledge that might help save lives in future events.